Okay, welcome to your free GRE prep hour. Today's topic is letting go, and this will be part of our Quant Speed Strategies series. I have a few videos on this topic where we run down various ways to be faster and more efficient on the test. And I don't want to imply when I keep returning to this theme that the most important thing on the GRE is going fast, 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 fast. To me, that's not the point. It's that there is a lot of time pressure and we want to be efficient. We want to get good return for our investment of time, and sometimes that means doing a problem fairly quickly. Sometimes that means slowing down in the right places. Sometimes that means knowing when not to do a problem at all, which will be a big theme today. But in all of this, I am not trying to hurry anybody, and I think that's very important. There's a very big difference between working quickly and efficiently and still carefully and accurately um, versus just kind of panicking and rushing. And I think a lot of people feel that difference most keenly. I hear this all the time. People feel that difference most keenly in the transition from practice to practice tests or the real test. Um, when they feel like they're just practicing, then they do their best, and if there's some they don't get, that's fine. They move on, they learn from their mistakes. But as soon as then the pressure is on, for some people that's on a practice test. Some people don't experience this until the actual test, but things drop and they have a much harder time because suddenly they don't want to let anything go. Then they feel the time pressure and they start trying to hurry. And it ends up with a really unfortunate situation where people spend extra time on the hardest questions, not wanting to let them go, not wanting to miss anything, and then end up having to hurry and make mistakes from rushing on the easier questions, and they end up just missing far more questions than necessary. I'll see someone who's normally getting, the majority of the questions right, maybe even 80, 90% of the questions right, drop down to where they're getting a third or fewer right. And that's not an exaggeration. I see that kind of performance fairly commonly, and we don't want to have that happen to you on test day. If it happens to you on a practice test, okay, we work around that, we learn from it. If it happens on the real test, ooh, that's just really unfortunate for you, right? And then you've got to go retest and pay again and do the whole thing, and we'd of course rather avoid that. So today's lesson kind of fits in this last part of the speed strategies, which has to do with thinking about your overall section strategy. Sure, in theory, if I'm looking at one question at a time, I just want to do my best on every question. But since I'm dealing with a time test, I want to be ready to let things go. Target time for quant is about 1.75 minutes, about 1:45. This is partly because the quantitative comparison questions at the beginning of the section, the ones with 2 columns, those are usually meant to be a little faster, maybe a minute, minute and a quarter, and then that would leave you more like 2 minutes for the rest of the questions. Today, I'm just going to allocate about 1:45 per question, even though these won't be quantitative comparison, just to get used to thinking about how you allocate your time. For the first set, I'll give you 2 minutes, and then for the others, um, we'll well, actually, we'll see how things go. We might do 4. Um, so what I want to do is I'm going to give you 2 problems, but I'm only going to give you 2 minutes. So normally that would be half the time you need. And what I want to push is this idea of decision making. Which one of these looks more worth doing, and which one of these do you not want to do? And I always want you to feel that power. Right? In some situations, we feel powerless, right? Maybe you're looking for a job and there's only one job offer that you get and you have to take it, right? And maybe you don't like the job or you don't like the pay or the benefits or you don't want to relocate, but you feel like you don't have any power because that's the only thing available. On the GRE, I want you to think of it as you've got a whole section full of offers and you're choosing from among them. Sure, if you're trying to max out the test and get a really high score, you may end up doing all of them. And I certainly want you to answer all of the questions. But you may, for most of us, we won't end up actually doing our best work on every single question. We're going to let some go in the interest of the overall. So I want to practice that kind of thought process. So in a moment, I'm going to put up a pair of questions. I want you to choose one to do, but I want you to commit to writing both answers down within 2 minutes, which means one of them will be a guess. If you're super fast, and you finish, one of the questions in a minute or so, then you might have time to engage. But assuming that that's not the case, and I think most of us that won't be the case, then we're really just going to do one and guess on the other. You could try to be an informed guess, but basically just a guess. So let me put these up. Decide which one you want to do. Take a moment to look at them. Decide which one you want to do. and then you'll have your 2 minutes. Okay, here we go. Try it out. Okay, there's your 2 minutes. So take a moment to make sure you have an answer written down for each of these questions. That might seem like an odd request considering the first one doesn't have multiple choice. It's just asking you for a number. That doesn't seem very fair. Okay, but if we're guessing on that one, guess. And you want to get in that habit, guess on every single question. Every now and then, I will luck out. I will guess on a question, having no idea the answer, even though it's not multiple choice, and get it right. Right? It's happened. I remember, sometimes it's just if it's a fairly small, number, but I remember being asked some math question years ago where I didn't even know what they were talking about. And I just sort of said, two? Yes. Oh, good. I look so smart now, right? I have no idea what they're saying. And so, this could happen. I wouldn't guess two here. All right. You might have a better guess than that, even if you don't know, how to do this question. But make sure you have things down written for both. Okay. So curious, which one did you choose to do? So one of you chatted me, you did the bottom one, another bottom one. Okay. Did anyone focus on the first one? Okay, someone did the top. How'd you decide? How'd you decide which one to do? Because that has to be a fairly quick decision, and then we might second guess it later and, wonder why we chose that. Mhm. So when we review, I think that's part of what we want to review for. Was this a good one to skip? Why or why not? Um, if the bottom looks like fairly straightforward algebra to you, maybe you just think you can do it, right? That's fine. If you're intimidated by the bottom, then you might be less likely to do it. And I'm realizing now that these fraction bars didn't copy very well. So if anyone's having trouble seeing what do I even have here, this is meant to be a fraction bar there and there. Okay. So someone might say, oh, that's just algebra. I know how to do that. And someone else might say, ooh, that's kind of ugly algebra to me. I think most of us are probably going to be happier with two than one, because if we don't like algebra, we probably also aren't going to like that equation in the first one. However, if you know the formula for a parabola and you're comfortable with what that H and K stand for, then that might be much more familiar. And that's one thing to think about when we talk about whether to do a problem or to skip it. Is it testing something that we are familiar and comfortable with? Often there are problems that are too complicated for us to kind of figure them out on the fly. We have to already know something about them. And that doesn't mean we've seen this question before, but maybe we've seen something like it. So I would say probably most of us are going to be happier with the bottom one. The top one, if you don't know the formula for an area of a parabola, you might find yourself stuck or guessing, although you might kind of logic it out to some degree. If the top one were multiple choice, also, you might be able to narrow it down. Maybe you'd look at the answers and say, well, -3n, let's see, -3 is over here. And so where does this parabola meet? Oh, I don't know how to scale this is, but like it seems like, pretty high up. I'm guessing that my answer will be a large positive number, right? That might be a reasonable guess. I know I just turned that into a straight line, but okay. So let's run through both of these and make sure that we feel okay. But we can start with the bottom one and see if we think it's as friendly as it looked. So what's a good first step here? If I'm dealing with this equation, what can I do? A good bit of recognition is that if a fraction is equal to 1, that means the top and bottom are the same. But honestly, even if I don't recognize that, I can also simply multiply both sides by the denominator, and I get that denominator on the right. And so one way or the other, right, I'm basically taking all this stuff and moving it up here, so to speak. Some people hate when I say moving, right, because you're really just canceling. You're multiplying the left-hand side by the denominator, and it cancels. You're multiplying the right side by the denominator, gets multiplied by 1. And the effect is that that information all ends up on the right-hand side. And so I'll end up with something like this. 3 equals m plus 1 over m plus 1. Some people might be cozy eyeballing this from here. You can certainly just plug in the answers, as one of you is saying, right? Whatever you're comfortable with. Careful you don't make too quick an assumption. Like someone might say, well, clearly I want a positive number because the answer has to be positive, right? Or the left-hand side is positive. But if I have two negatives, they might cancel. The one I don't want to test is 0. Why not? While doing that, I might move this over. Yeah, as you may know, you can't divide by 0. So, some people think of it as a rule, and I think of it as more just like, what would it mean? If I say how many zeros are in 10, right? What do you mean how many zeros? Zeros are nothing, right? You can take I can give you $0 all day, right? If I have $10 and I don't lose anything, right? So dividing by 0 just doesn't mean anything. And so if m were 0, this would not be 2. It would be undefined, right? It'd be 1 over 0, which would be undefined. So we can test cases here. However, I could also just move this over. Whatever you're comfortable with. And I get m equals 1. The more involved the work is to simplify, the more you might be happier testing cases. On the other hand, the nice thing about simplifying is you do it once and you're done. Whereas if I test -2 and it doesn't work, then I have to kind of run through it all in my head again with -1 and with 1 and with 2. And so, it's a trade-off. But I'd argue that if you know your moves here, then this isn't such a bad question. One really important thing, though, to look at with these is not just, is it hard? Do I understand it? Those are good questions to ask. But also, did I get it right? And was I in danger of not getting it right? Sometimes people will look at a question and go, oh, that's easy. It's fine. I want to do that one. But then they don't recognize that there's a lot of places where they might make a mistake. And so if you miss this one, even if you understand it very well, even if you don't think it's very hard, if you missed it, take that seriously and say, okay, so what happened? What threw me off? Even if it's just something as simple, someone might just accidentally really quick say, I don't know, like 6 times 3 is 12. And then they might go, wait, no, 18, whoops, right? But if that work state, if they wrote 12 on their paper and then solve with that, they have to look at it and say, why did I say 6 times 3 was 12? Was I rushing? Was I doing too much in my head? Is that something I need to work on? Like, I don't want to go back to elementary school and drill my times tables necessarily, although sometimes I need some of that. But I might think about what contributed to that problem. Okay. Let's look at the other one. I think, again, most of us might find this harder, but not everyone. The idea with this is that this is a standard formula for a parabola. And basically, in this formula, the vertex of the parabola is going to be H and K. So those will be the X and Y coordinates of the vertex of the point at the end of the parabola, right? The dot at the end where it's the lowest point, or in some cases the highest point, right? If it's an inverted parabola. One way that I remember that, right? One way I stick with it, and honestly, sometimes when I haven't remembered the formula at all and I'm just trying to make sense of it, because some of these formulas are not things I do all the time and I can forget them just like anyone, is I'll look and say, what I know in general about a lot of graphs is that generally when I have my X term and I subtract from it, it moves it to the right. And when I add to it, it moves it to the left. Sorry if that looks opposite to you. But it's can be somewhat counterintuitive to people. You might think adding puts it further over to the right, and subtracting puts it to the left. But it actually goes the other way. When I'm subtracting, it puts it to the right, because I'm treating it like how would I say this, right? When X is 2, I am treating it like it's 0. And so everything happens kind of 2 over, right? So it's just something you can memorize, right? So what I then know is if you imagine just a plain parabola, like y equals x squared, right? If I had just the equation for y equals x squared, it would look like this, roughly, centered on 0, 0. And so if it's 2 over, that's the -2 here. And then is it up any? No, it's not up any. This is 0. If I don't recognize that, it's going to be hard, because I might think, oh, I can just plug in this one point. But the problem is, oh, wait, I don't know that point. That's what they're asking before I want n. I can plug in this point, 2, 0, but that gives me an x and a y, but then I have 2 unknowns, h and k. So if I don't recognize what they're testing, it's pretty hard to do. But once I know that, then I can plug in the point that I want. I can say, oh, I know that y, which is my n, is going to be my x, which is -3, minus my h, which we've defined as 2, squared, and then plus k, but that's plus 0, so just nothing, right? In fact, we can just say, hey, there is no k term here, right? And what I'm really getting then is n equals -5 squared is 25. That might be pretty hard to just randomly guess, but like I said, we could have predicted it would be a fairly large positive number. If it were multiple choice, we might have picked 25 out of the lineup. On a fill in the blank, the price we pay for skipping a fill in the blank is we're not very likely to get it right. But if we're not going to be likely to get it right if we do it, or if we're going to pay too great a price for it, if we're going to spend 3-4 minutes on it and have to drop something else, then it's worth it to miss it. However, this is a good reason why we want to watch our time management earlier in the test. These fill in the blank ones, it's kind of mean, but they tend to come right at the end of the section. Maybe not the very last question, but usually near it. And it's kind of a penalty if you've run out of time, right? Whereas the early questions in the section, the quantitative comparison, are 4 answer multiple choice every single time, always. So you have a 25% baseline on those. And if you can get rid of one of the options, right, you start narrowing it down very quickly. If you can test even one case on quantitative comparison, you can always get rid of 2 of the options and you're at a 50-50 already. So in those, there can be actually a benefit to moving a little faster, even if you're not 100% sure, so that you do have time to actually do the questions at the end of the section. But everyone's trajectory is going to be a little different. Okay, questions on this? Okay, let's do another time set. So here I'm going to give you three questions. Sorry for the terrible graphic design. They're kind of sitting on top of each other, but I know sometimes people have trouble reading the screen if their devices are smaller. So I didn't want to make the font too small, but I wanted to fit three on to get that time crunching. So I've smashed three questions that are fairly large onto the screen. I'm going to give you 4 minutes. So I won't do 3.5. I'll do a full four. But I want you to do 4 minutes to do three questions, which means I'm still forcing you to guess one, right? Now you may not be in this situation on the test. Maybe you can always finish with time to spare, and more power to you if you do. But I think it's good to recreate this, and I see this even with my most advanced students, because they'll be there going, "Oh yeah, I feel great about all the practice problems. And when I do official guide problems, or when I do problems out of your um, Manhattan Prep 5-pound book of practice problems, I'm able to finish them all on time, and I get most or all of them right. And then on tests, it's another story, right?" And so I want you to, in those cases, create a problem where there wasn't one, right? If you're always finishing problems with time to spare, recreate what might happen on the test and give yourself that pinch situation. So I'm going to give you 4 minutes to do all three of these questions, but I would recommend strongly that you don't try to do them all fast. Don't go 120, 120, 120. Pick two, but put down answers to all three. If you happen to get done with the two, doing your best work, and you still have time remaining to think about the third, then great. But commit to answering all three and take maybe a moment to look these over and say, which of these do I think I'm most likely to skip? Um, okay, so let me get my clock ready. Okay, here we go. Okay, there's 4 minutes. So which of these lovely problems did you decide that you could live without? We were to number them. All right, 1, 2, 3. Which of these problems did you choose not to do? The last one. Now that's cool as long as it's not by default. If you were just like, I did the first one, I did the second one, I was out of time, right? Um, the last one I think is pretty intimidating. Again, the downside of guessing on one like this is you probably won't get it right, right? So take a moment, by the way, if you haven't already, to write down your answers for all three. So for 1 and 2, that'll be a letter, and you have a 1 out of 5 shot built in. For number 3, it'll be a number. Probably not going to guess this one if you didn't do it, but you can still put a number in anyway. You never know. You got better odds than the lottery or something. Okay, so I will say about number 3 though, there's a trick, right? There's got to be. Uh, if it looks like I'm supposed to add all those numbers, yes, I have a calculator. I could technically go -2 plus -1 plus 1, but I don't know about you. I will make a mistake somewhere in there. I will mess up. I'll fat finger one of the things and mess that up. So probably don't want to do that. If it seems like we're supposed to do a ton of calculation, or if it seems like we're supposed to be some brilliant math savant, there's got to be a trick. Now, that doesn't mean I know what it is or that I want to do it, but I want to think about that when I'm doing these. So skipping to number 3 that we mostly didn't do, can you see where the trick might lie? What's going to make my job easier if I want to add all these numbers up? Yeah, look for patterns, right? There are various ways you can see the patterns, but there are a lot of negatives and positives that cancel each other, right? Um, and so if you think of it as like, oh, look, I have -2 and -1, and then +2 and +1, right? I might even just, maybe the most clear one is these right next to each other. Oh, well, these are all going to cancel each other. So they're like nothing. I just don't need them. Of course, I can't mark on the screen like this, and I don't want to recreate this box on my paper. So I'm just doing this as a mental tool for us right now. But I could then also recognize, oh, wait, but then these other ones also cancel, right? These -2s and 2s. Okay, look how Christmassy this package is looking. Merry Christmas, everybody. All right, let's see. Okay, so then we're left with this, and it's kind of a mess. You might know some patterns for adding up successive multiples of 3 or 4. If you put those together, they're making 7s, right? So we got 7 plus 14 plus 21, right, etc., like this. So maybe I'll draw a little smaller. So I could add up 3, 6, 9, 12, 15, 18, and 4, 8, 12, etc., but I might as well do it together. This is 7, this is 14. And if one keeps growing by 3 and the other by 4, then they are growing by 7 really consistently. And so I can start going, oh, hey, I know my times tables. Again, hopefully. But I do have a calculator as needed. Okay. So I could just add those up. I could put them on my calculator. I might also just notice this is 7 times 1 all the way up to 7 times 6. And there's a formula for adding up consecutive numbers, right? The sum of 1 to 6 is going to be the median times the number of terms, which is, and then we're not doing 1 to 6, we're doing 1 times 7 plus all the way up to 6 times 7. So it'll be 21 times 7 is 147. So that's one way to think about it if that's not your favorite. The other way is including just punching them in, right? But that's the idea. You could also just directly go and say, again, the average times the number of terms. When you have an evenly spaced set, like 7s, then the average will be, oops, then the average will be the average of the ends, right? So, ooh, the disappearing ink, that was fun. So the average of the ends is 7 plus 42. And the multiplied by how many terms there are. which I might write out as 49 times 3, which is 147. Okay, so different ways to do it. So you might feel very justified now, like, yep, I skipped the right one, and maybe you did. I think there's certainly a case to be made that that's the hardest of the three. And so recognize that it's important. You do pay a price in that, again, you probably didn't guess 147 if you didn't do this, right? And if you did, I would love to know how. But if you had multiple choice, you might get partway and eyeball it, right? Or you might just look at this and say, oh, it's over 100, guess something in there. But this is going to be probably a miss if we don't do it. But that might be worthwhile if that allows us time to do the others. Okay. Did anyone skip number 1? I think this is an example of one where we might skip it if we were in a hurry because we might think, oh my gosh, I have to learn about some different measurement system and I don't want to read this and it's giving me a headache. But I think if we stop, take a breath and read it, oh, it's not so bad, right? Because all they're saying is a crown equals 10 inches and a scepter equals 14 inches. So a crown equals 10/14 of a scepter. Another way you could say that is the ratio of crown to scepter is 5/7. Now, if I'm converting from crowns to scepters, should my value get larger or smaller? So do we want to watch the difference with conversions? If I, like, I don't know, if I'm getting paid in a currency that's only worth, a fraction of a US dollar, and you change it to pay me the same number of US dollars, then I'm happy because I get more money, right? But if you simply change, the number you're giving me, right? If my currency is worth 1/10 of a dollar and you just convert the currency, you're going to give me fewer dollars. It's going to equal the same amount, right? So although scepters are more than crowns, when we convert from measuring crowns to measuring scepters, the number should go down because you'll need fewer scepters to make the same number of crowns. So we want to predict that the answer has to be less than 70, yeah? The answer has to be less than 70 because you'll need fewer scepters. You'll need fewer 14s than you will 10s. And specifically, we just want 5/7 of 70. That's the whole problem. But it's really easy to go the other way, right? And then we get ourselves in trouble. If we did 7/5, however, then we'd say, okay, that would be 98, and then we'd get E. So we have to watch for that. So one thing that can be useful in terms of strategy is a little bit of redundancy. Don't just do out the math. Also think about a prediction and make sure it makes sense. Now, could I still be wrong? Sure, I could say, oh, I want my number to be larger. And so looking at this ratio, I'm going to do 7/5 and I multiply it by it. I'm still working with that assumption. But if I kind of write it out one way and I think about, does that work logically? How can I be sure? What do I expect to see when I measure these? Sometimes I can get at the answer a little bit more independently and a little bit more likely to catch it if I'm wrong. Okay. Questions on this? Okay. You might also suspect that half is a bad answer, right? If something is 70 in crowns, scepters being 35, you'd expect that meant a scepter was twice a crown. Or if you got flipped around, it might mean a scepter was half a crown. But either way, it's not either of those things. And so I would get rid of that one. Okay. Let's see. Go ahead. Let me have you pull this one in. What'd you get for this? So I'm going to give you the answer poll. This one in. I don't think anyone said they skipped this one. We might have said, oh, fractions. I know these. Still easy to get this kind of thing wrong, though. So we do have to stop and slow down on them enough to have them. And that's partly the advantage of letting one thing go is that you have the, I don't want to say luxury, but you have a little bit of room to slow down and get the other one. Fractions are something we often learn when we're fairly young, and we feel like, okay, I've got those, and then they can get pretty hard on the GRE. Aside from the fact that we may have to relearn them, right? But they can get a little more challenging than what we might do when we're kids. Although even the kid stuff gets pretty interesting. I used to teach elementary school, and I remember when I was first training as a teacher, trying to do some fraction exercise with kids, and just thinking about what constitutes a whole. It's all very nice to say, I'm going to take a third of the circle, or I'm going to take an eighth of the pie, or circle 1/10 of the marbles or something like that. But when you start talking about more than one item, like here we have two pies, thinking about what a whole means and what I'm taking a fraction of is very important. So you also have to just read really, really cautiously. So a lot of folks, I would say the majority of folks here actually miss this question. And it's not because they're doing such a lousy job. It's not necessarily an easy question. It just doesn't look maybe as intimidating as some of the others. If I take two pies, am I supposed to be cutting each pie into 16 pieces, or am I supposed to have 16 pieces of pie total? What does the problem say that I'm doing? It says 16 pieces total, so I only want 8 each, right? So if the whole is two pies, and we're cutting that whole into 16 pieces, then an individual pie is being cut into eighths. And I know that each person is just getting a fraction of that. So I know it's not going to be something very large, right? I'll probably get rid of these. Certainly not 3/8, probably not even 3/16, which is, easing up on a quarter, right? So if I imagine chopping these into eighths, I don't really have to visualize it on both, right? As long as I have the idea, I'm good. It certainly doesn't have to be perfectly drawn, which is a good thing because I'm not so much the one to hire for perfect drawings. But that's an important thing we want to catch right at the beginning. And a lot of people ask me as if like I'm the bearer of the knowledge. And in the end, you have to say, well, were they clear? And they have to be clear. So what were they saying? So these again are not very equally drawn. But the idea is that each of these is an eighth. Right? So if each of these is an eighth, uh, and then I'm taking one of those pieces and split it among three. And when I first did this one, I was also thrown because it said, how much does each person get? And I was like, wait, does each person get one of those first pies? And how many people are they? No, no, no. They're just talking about the three people. They never talk about anyone getting any other pie, right? They said it was cut. They didn't say it was given. So we want to watch that distinction. They do have to be clear. They never said anything about giving anyone the other pieces of the pie. So they're just talking about this one slice that's equal to a third. And so we're chopping that up. That's about what my pie slicing skills look like. So each of those is going to be a 24th, a third of an eighth. And that's our answer. So watch out, if you got a 48th, I think I know what happened, right? You probably divided each pie into 16 pieces. So it's watching exactly what they say and taking them very literally. Okay, that all right? Okay. Well, let's try another set. So same deal. Again, think about where you want to spend your time. I'll give you 4 minutes. Make sure you're putting down answers to all three. You'll notice that the second one is an indicate all such values. So if you do that one, you need to potentially click more than one answer or write down more than one answer. Okay. Your 4 minutes starts now. Okay, that's 4 minutes. So which one did you do without this time? First one. We'll put you off of the first one. Function just kind of scary. Okay, I'm saying, yeah, I figured you missed. Okay, B, second one, yeah. So just what does this mean? What is H of something? What is that telling you? Function questions are a really good example. That's what that is a function, right? A really good example of the kind where you can just be completely stuck like a non-starter, like the math problem I said I saw as a younger person going, I don't even know, two, right? Where we just don't know. We don't know what they want from us. But when we do, they're often not that bad. Maybe that's kind of like the parabola problem. Once you have the piece that you need, they're not that bad. Sometimes that's a piece that they give you. In other words, there's kind of a brand of function or formula problems where they define a term. They'll be like the concatenation of two quantities is equal to the blah blah blah, and they'll just tell you what that means, right? They'll just, even if it's a made up term, the interstitial range or something like that, or okay, I'm making up things that really are things, but um, they'll tell you what something is, right? They'll give you some Greek letter, and they're just going to be like, here's what to do with it. So there's a bit of that here, but not entirely. Okay, the second one, um, clearly when there's indicate all such values, that means we might have to test a lot of things. There might be a principle for doing it that saves us time or trouble, but it might be a lot of work. Once again, if we skip the second one, it's not quite the same bad odds as fill in the blanks, but it's a little worse odds. We don't have a 1 out of 5 shot this time because there's so many possible answers, right? Including all the way up to all of them. The answer can't be none. There has to be at least one answer that you'd click. But if you think about your combinatorics, there's 5 possible single answers, and then another 5 sets of 4, et cetera, et cetera. So lots of combos. Your chances of getting this right, if you guess, are kind of low unless you know something. The third one, did anyone skip that one? Some people just kind of instinctively skip anything about probability or combinatorics, but they're not always so bad. The nice thing about this is there's also a middle ground on a probability problem where you might have a sense of what the answer is, even if you don't know exactly what it is. You might know the neighborhood that it's in. For instance, you might just be able to reason about whether it seems more likely than not. And you'll notice on that last question, there's a pretty stark divide in that 3 of the answers are less than half, and the other 2 answers are more than half. And so you can simply say, does this seem likely or unlikely? Does it seem, and of course you can subdivide further. Does it seem very unlikely, very likely? Um, okay. Well, let's run through all of them. So the first one, so what, if anything, makes this hard? Partly it's just what do they mean when they say h of x? And to some extent, they're telling you, but that might not be a comfortable thing if you haven't seen that notation before. So in general, when you see f of x, h of x, g of x, whatever, um, even if you see, like I said, a Greek letter or some weird symbol applied to it, it just means do this. So they're saying whatever you see in parentheses, uh, square it, multiply it by 5, and add it, right? Um, that's what we're doing. So if I had, what if I had h of 3, for instance? I'd say, oh, that's going to be 5 times 3 squared plus 3. Yeah. So 5 times 9 plus 3. That's not what the question's asking, of course, but give me that. So h of 3 would be 48 because I would just plug that number in. And one option I have here, even though they didn't give me numbers, is I could make up numbers. I could be like, all right, well, what if I make this 3? What if I made A2 and B1? Then h of 3 would be 48, and then I'd be looking for 48 as an answer. picking values is a very valuable tool to use on this test. So I could say, let's see, would this be equivalent? If A is 2, then this would be 5 times 4 plus 5 times 1. That doesn't look like 48 to me. I don't care what it is. I think you probably know what it is. It's 25, but I don't even need to calculate it. It's not 48. 5a cubed. Ooh, I'm cubing stuff now, but thankfully I'm just cubing 2. 2, 4, 8. 5 times 8. Oh, that's 40. That's promising. And then b cubed d1 still. So that's 5. Oh, that looks like 45. I'm getting there, but no. I can start reusing stuff. I already know what 5a squared is. And I already know what 5b squared is. And then I'm going to have plus a plus b plus 3. Okay, that's too small. I already found out what 5a cubed was. That was 40. 10ab, ab is 2, so that's 20. Oh, that's already too big, so I don't even care what 5b cubed is. So then here I'll repeat 5a squared is 20, 10ab is 20, 5b squared is 5, a is 2, and b is 1. Oh, let's see. That's 48. So one way to do this is just to pick numbers and see what happens. But to do this, I still do have to recognize what they mean when they say h of x is 5x squared plus x, which just means plug all this in. Now, if you want to make it even easier, it's about recognizing what happens when you square a sum of two things. And this is something absolutely memorize. There's these quadratic templates. And we often memorize them with a and b anyway, so here it is with a and b. And there's 3 of them. I want to know what a plus b squared is. I want to know what a minus b squared is. And maybe you already do. But if you don't, high priority to memorize. I don't really nudge people about memorizing a whole lot of things. I didn't say memorize the formula for a parabola. If you do, great. But honestly, it might not come up. It probably won't come up. Whereas these probably will come up. So if you ever forget, you can multiply them out. If you haven't done quadratics in a while, it's first, outer, inner, last FOIL. You just multiply a times a and a times b and b times a and b times b. In other words, you multiply everything times everything else. And you end up with a squared plus 2ab plus b squared. And this is a pattern you can memorize. If you do a minus b times a minus b, notice that the a terms still give you a squared. The negative b times negative b still gives you b squared. The only difference is the middle, where you'll get this. So if it's been a while, my point is not to teach quadratics right now, but I am. So that you can delve into in more detail later. But these are very, very valuable to memorize. So flashcard these 3 if you don't have them down entirely. Now, why am I talking about this? Because look, they're asking me to square a plus b and add x, add it, right? So h of a plus b, according to the formula, is 5 times a plus b squared plus a plus b, because a plus b in this case is our x. If at this point you're saying, I'm so glad I skipped this one, fair enough, although you might like the number plugging thing I did, you might, right? So if I recognize then that a plus b squared is just this, you don't have to think of it all at once, you can plug it in now. You can say, oh, so I gotta have 5 times a squared plus 2ab plus b squared plus a plus b. That a plus b doesn't connect to any of these because they're all either a times b, which you can't add to a, or squared terms. So I just distribute the 5 to the terms that are in the parentheses. 5a squared plus 10ab plus 5b squared plus a plus b. And that's how we end up with the answer we got. You might like the plugging numbers better, but this works. And this will be the fastest way if you have the instant recognition, which maybe some of you did if you're up to speed on your algebra. Okay, so that's the value of knowing those. Thoughts, questions on that? So if you're feeling justified in skipping that one, sure. But then you think about, okay, would I have to skip it in the future and how would I know? One thing I want to be clear is I'm not making the point that out of every 3 questions, you should skip one. You might end up skipping that many. Most people will certainly miss at least that many, and so they can afford to guess, especially if the guesses aren't always entirely random. It's more that you want to get used to forcing the issue and guessing things, and even having some of these kind of tough timing situations where you have to make those decisions. So you're ready to do that on test day. Um, and that's like anything. It's like if you're used to having like a ton of money, well, give me some. No, if you're used to having a ton of money, then you might not ever have to make like tough decisions about how to allocate it. Oh, I always have enough to, when I go to the restaurant, I can just order all the things that I like on the menu and I don't worry about spending money. And oh, if I'm not sure, whether to go on this vacation or that vacation, I just go on both of them and yay, right? But then when you have to tighten your belt, or when you're trying to like run a company and, allocate the resources in the budget, at some point it gets really hard because how do you make those decisions? Right? And so we want to make sure that we're used to having to make those calls. Okay, quick run through of the other two. This one is asking, what's not a multiple of 64? How do we tell if a number is a multiple of 64 other than just dividing it, right? Because some of these I can just see, or I can just divide. But if I start getting to things like 30 to the third or something like that, I don't want to like actually find out what that is and then divide it by 64. So how do you know if something is a multiple of 64? In general, we can say X is a multiple of Y if X includes all the prime factors of Y, including, however many number we have of them, right? And 64 is just made of twos. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 64 is 2 to the 6th, right? So a number is a multiple of 64 if it has at least 6 twos in its prime factorization, right? When you break it down, you get at least 6 twos. Now they're talking about, what about 12 times a number, right? 12 is 2 times 2 times 3, so it contributes 2 twos. So to make a multiple of 64, our number needs to bring in at least 4 more twos. So does this have 4 twos in it? And when I mean 4 twos, I'm not saying like 4 times 2 is 8, right? But 2 times 2 times 2 times 2, 16. So you could also say, is it a multiple of 16? Now, you might say that's not that much different than asking about 64. I don't know whether these things divide by 16. I don't want to find out what 6 to the 6th is, and then divide it by 16. Instead, I just want to say, hey, each 6 has a 2 in it. So if I multiply 6 to the 6th power, it's going to have 6 twos, right? It's going to have 6 twos because each 6 has a 2 in it. So this one is a multiple of 64. So I'm going to say yes to this, which means I cross it out. That can be really easy to get turned around on. So I usually recommend writing down yes or no and then checking to make sure you're doing the right thing. So this is a yes. What about 12 squared? 12 has 2 times 2 in it. So this will be 2 times 2 times 2 times 2 in there. Oh yeah, that has 4 twos. That's a yes. So I would not pick that one. 18 is 2 times 3 times 3. This is just going to have 3 twos. That's a no. 30 is 2 times 3 times 5. So it just has 1 2. So this would be 2 times 2 times 2. And then 222 looks very 2-y, right? But it's 2 times 111, which is odd. So this just literally has 1 2 in it. So that's a no. And odd numbers are never multiples of 2 because that's what odd means, that they don't have any 2's in them. So I want to check what I want. I want the no's. It's these 3. So here's one where if you skipped it, you might be saying, yeah, that's why, because I am not used to doing this. And this is kind of one of those ones that if you don't have a thing for it, you're not going to guess, very likely, right? And I don't just mean that you're not going to guess randomly and get it right. I mean that there's not one where you could just eyeball it, I don't think. I think you really have to know exactly what you're looking for. Oh, I'm looking for 6 2s. I got to pull 2 out from the 12s. I need 4 more 2s, and I got to be able to count those up. If that's not comfortable, then this is a smart one to guess. And I would say, to be blunt, like a lot of people should not do this problem. Like, shouldn't do it. Right? Doesn't mean they can't understand it. It means that under 2 minutes time pressure on the test, they're not likely to get it right. And so if that's true, it's important to acknowledge it. Right? Very important part of this test. It's never about, can you do the problem? It's never about, do you understand it? Are you smart enough? Are you worthy? It's only about, am I likely to get the right answer in the time that I have? Okay, let's wrap this last question up. Go ahead and pull this one in, whether you feel guessy about it or whether you feel like, put an answer. One thing to watch with things like greater than, make sure you're distinguishing between greater than or equal to or greater than, right? Sometimes we use that loosely. Like if I say, are you older than 18? And if you're not, wow, congratulations, I'm already prepping for grad school. But if I say, are you older than 18? Usually that includes being 18, right? Like, oh, if you're older than 18, you can vote, right? If you're older than 18, you're an adult. But technically I'm saying if you're 18 or older, right? So the GRE will never be that imprecise. If they say greater than 4, they mean greater than 4, right? So in other words, they want the chance of 5 or 6 on at least one roll. Okay. So I think what we can hopefully agree on is that the chance of getting a 5 or 6 is not that great, right? In fact, we know exactly what the chance is on one roll. The chance on one roll is 2 out of 6, or 1/3. In other words, this is the number cube, also known as a die, right? When you roll the die, there's 6 sides. 2 of them have a 5 and a 6. The other 4 don't. And so your shot of getting that is 1/3. Now, a quick answer could be, all right, but I have 2 chances. So one answer, it won't be right, but it might make sense, is to say, so is it 2/3? You wouldn't be too far off. And I think there's a good reason to suspect then that if I have a 1/3 chance on one die and I get a second chance, it can't be less. It can't be equal. I have to improve my chance. And that's like anything, right? Think of it again, I mentioned the lottery. Like you're probably not going to win the lottery ever. Sorry. But it is true that if you buy a ticket and you don't win and you get another ticket, you're more likely to win than if you hadn't bought another ticket, right? It still increases your odds, even if it's minuscule, right? So it has to go up from 1/3, but how much? It seems pretty sensible to say that it's more likely than not, because you get those 2 choices. I'd probably be suspicious of C, and no one picked that. But this might drive me into the arms of D, because 2/3 just seems a little nice. It's like a third and a third. Is it really there? So why isn't it 2/3? There's an issue of overlap, right? If I get it right on the first roll, I don't even need a second roll. Like it's fine if I do, but there's a little bit of overlap going on. So in some of the cases, maybe I'll get 6 both times. And then the chance of getting it on the second roll doesn't really have anything to do with our answer. In other words, a third of the time we'll get it right on the first roll. And we're only really concerned in terms of adding to our chances of ones where we didn't get it right the first time and we get it right the second. So I think the tough way to see that maybe would be to say chance of, like a win, if you want to call it, on the first roll is 1/3. And then chance of lose, then win, you'd say, oh, well, let's see. The chance that I don't get what I want is 2/3. And the chance that I then get what I want is 1/3. And so the chance of those things happening together is 2/9. And you put those together and you get 5/9. If that doesn't do it for you, I think an easier way to do it would be to use what we call the 1 minus x trick. And this is a very common trick in probability, right? What's the chance of not getting what we want? And this also kind of proves if what I'm saying doesn't seem logical to you, this can prove it. You say, all right, so if I don't win, right, if I don't ever get a 5 or a 6, then the chance of getting a 1 through 4 is 2/3. And the chance of getting a 1 through 4 again on the second roll is 2/3. Which is 4/9. So the chance of not getting what I want is 4/9. The remaining 5/9 must be the chance that I do get what I want. There's only those two choices, right? Either I do get it or I don't get it, right? So 1 minus 4/9, that's a chance that I do get what I want. Okay. So some of you might say, oh, probability, got to go back to the drawing board on that. And this is, again, certainly one that you might skip on a test, right? And I want to also leave a moment of room for anyone who's feeling like, I needed to skip more than 1% to be sure, not because of time, but because I don't know how to do these. And I know some of you said you're just getting started, and so be forgiving with yourself. You might skip a problem on the GRE and immediately need to skip another one, right? Fill in an answer, keep going. And then the beautiful thing with this test is at the end of the section, if you have time, you can always go back and play with them. But also if you're just learning, you might say, all right, yeah, no, some of these things I'm just not going to do. Um, you just have to be careful if you're then investing extra time in the ones you do know how to do. Be careful because as you learn more, then that issue kind of goes away. In other words, maybe initially you're skipping a third or quarter of the questions or more because you don't know how to do them, and then you're slowing down on the others. But as you fill in the gaps and learn the missing material, now you don't have as many of those automatic skips, and you have to contend with the timer a little bit more. And some people really crash on their second practice test because of that. So my general advice is stay in the neighborhood of 2 minutes per question. Don't skip questions in order to run really long on the others. Skip questions in order to stay on track, and invest small extra amounts, 15 seconds here, 20 seconds there on finishing up a problem where you're on the right track. Okay. Well, I will stop there. Um, Thanks so much for joining us. If you want to check out any of our classes, you can always sit in on class 1 and see what you think. Make sure it's a fit for you. If you want to check out any of our other lessons, I have got a whole series on these speed strategies. Hope you find them useful. And of course, we have verbal lessons as well. All right, everybody. Well, thanks so much for coming. Best of luck to all of you, and hope to see you around. Take care.